Okay, level 2 exercise, 5 questions are quite tricky to be fair in these ones. We'll just work our way through it. A variable rectangle, so I drew out a rectangle of x and y because they change, has a constant perimeter. So the perimeter is 2x add 2y equals 20. So I can rearrange that to get y equals. You want the area to be a maximum. So area is x times y. So put your y in there for this in for your y, times it all out, and normal process. dA by dx equals 0, get your x. Don't forget to do your second derivative, prove its maximum, and then find the length of the sides. So that's your x and your y. Number 2, very similar to the example we did. A side of square x is cut from the corners. The card is folded up to give you an open box. Show that the volume is this. So 24 by 15. The wee corners coming out, so that length of the base is 24 minus 2x. The length of this base is 15 minus 2x. So volume, length times base times height, just as before. Maximum, you differentiate it, set it equals 0. You see me working through that. You can use factorize or use the formula. Second derivative, put in your values to see which is positive and which is negative. And then you want the maximum volume. So take your answer and put it back into one of your volume equations. I put it back into that one. Number 3, a cylinder. Now this is quite tricky. A cylinder is cut from a solid sphere of radius 3. So this is my sphere. The height of the cylinder is 2h. Find the radius of the cylinder. So if you can imagine the sphere fitting in here. Okay, diameter of a sphere is 6. So to find, if you see here to here, that's the radius of the sphere inside. If you use Pythagoras' theorem in there, 3 squared equals h squared add r squared. So r is going to be 3 squared minus h squared. It's very tricky, that wee one, to be fair. Show the volume. Volume is the area times the height. So pi r squared for area of a circle times the height. Putting in your bits and pieces. So you've got your volume. You want max, the rest of this is okay. In the exam, if there's a very tricky question, they will tend to say show that. So you can use the V they give you in the question to run through the rest of it so you're not stuck. So even if you couldn't get to here, you can then start in at part 3. So dV by dH, just differentiate its normal, put it equal to 0, find your h, do your second derivative, find the maximum volume. So all of that is as you normally would find it, but that's a very tricky question. Question 4, a cylindrical oil tank, so I would draw out so that the sum of its radius and its height, so radius plus the height is 24, so I can rearrange that to get h equals volume, put your h in there, times it all out, dV by dr, just as normal. Work out your r's, put them into the second derivative to see its maximum, and the question wants to find the max volume. So just make sure you put it back into the volume again at the end to give your max volume. And number 5, a cylindrical can of height has a capacity of 2 litres. Now that means its volume is 2 litres, which is 200 millilitres, which is 2,000 millilitres, which is 2,000 centimetres cubed, which is 0.002 metres cubed. The volume is pi r squared h, so we work out the h there. Now it's looking for the surface area. Surface area is the base, which is a circle, pi r squared. The top is also a circle, pi r squared. And the main bit is the circumference times the height. Remember the circumference is pi d. So tidying it up, 2 pi r squared plus pi d is 2r. And your h from up here. Work out your surface area. For the minimum or maximum surface area, differentiate it, set it equal to 0, get your r, differentiate it again, put your r in, you find it's bigger than 0, so it's minimum, and the question just wants the r value.